So in this demo, we're going to talk about torque. So torque is R cross F, right? So if you think about this hinge point here, this stick, this meter stick can balance around this point. So let's say if we're talking about this weight, it's 200 grams that we hang this mass, it has a certain weight. And that is a force of gravity pulling down. So there's a moment arm, so there's some radius from the place where the stick is trying to rotate to the weight. So that's your R. So you can use your right hand, use the right hand rule to figure out where the torque is. So you go R, put your fingers along R, you curl towards the force of gravity, the force down in this case, and then you'll see a torque that's pointing towards you. So that's your right hand, right? So R cross F, that's your torque. So there's a torque pointing towards you, and as you can see that if I let go, that's going to cause the meter stick to rotate. Torque will lead to angular acceleration. That's Newton's second law for rotation. So to balance that, we'll use the same amount of weight. We'll put it on this side, right? So now you'll see the two torques are applied, and then they balance each other. So we'll do the right-hand rule on this. So you have an R this way from the point of rotation to the weight, R cross F. The force is downward, so you go R cross F, and your thumb points towards me now. So the two torques are pointing in opposite directions, and therefore they balance each other out. So you might look at this and say, well, no big deal, they're the same weight, so they kind of expect that. But you can do this with a different weight. So let's take something that's a mass of 100 grams. And you can produce the same amount of torque that this was producing so long as you have a longer R. So here I'm going to go further away, twice as far away. So half the mass or half the force now. And because of that, I'm going to move twice as far away. And now again, R, right? So this is your R from this point to this point. That's your R. Cross, downward, that's the force. And then you still have a torque pointing towards you. And you can see that if I let go, that is in balance. That's because still the torque produced by this mass is counteracting the torque produced by this mass, and then they're in balance. So this is a demo of how you can have torque and have that in balance even if you have different masses involved.